Woohoo! We are live! Yay! And this is algebra! Yay! And we are multiplying, and we are dividing, and we're using radicals, and we're having so much fun. And this part is maybe a little bit more exciting than the rest, so make sure you're surrounded by people who are going to give you a lot of support and tell you you're awesome and maybe dance with you. And also, I've invited Square Bear because, you know, radicals, we're going to deal with Square Bear. And in previous videos, what we were doing was we were talking about multiplying and dividing radicals when everything goes well. And this is the video to talk about what if everything does not go so well? What do we do when things are just really hard? And the answer is, well, cry is one option, and, you know, gnash your teeth, certainly, make weird little puppets, and, you know, have dance parties with them. But also maybe we will just rationalize the denominator. So let's talk about what the heck I'm talking about. So first off, on a very hastily created card, I've got the rules of radicals. If you can simplify a radical, do it. You have to. No radicals in the denominator. No fractions inside of radicals. So basically, nothing sketchy in the denominator. And if you can simplify, you are required to simplify. I know, everybody's favorite thing. Yay! That is called simplest radical form. And we're going to work on that with this problem. And we're going to start with the example of 3 over radical 2. And this violates one of those rules because we've got a radical in the denominator. Denominator. There we go. Okay, there's a radical in the denominator. That is not okay. That is very, very, very bad manners. So this is how we're going to approach it. I see that it's 3 over the square root of 2, or the principal square root of 2, or simply radical 2. And so what I'm going to do is I'm going to multiply times an expression. And we love doing this with fractions. We're always multiplying fractions by expressions that equal 1. Radical 2 over radical 2 equals 1. It's the same thing top and bottom. So we're keeping it balanced top and bottom. It's a lot like an equation. We balance left to right, but fractions, we balance top to bottom. Okay, so I'm going to multiply by radical 2 top and bottom. On top, 3 times radical 2 is 3 times radical 2. There's not much we can do to simplify that. But on the bottom, in the denominator, I've got radical 2 times radical 2, or square root of 2 times square root of 2, regardless of how you want to say it. Since the radicals match, I can stick those two 2's inside the radical together. So then I've got the square root of 4, and that is actually equal to 2 in the denominator. So notice in this one, the radical is in the numerator. Now, if you are a normal human being and not, say, someone with an advanced degree in mathematics, you would look at these two and you'd go, I don't see a lot of a difference here, maybe. You would say there's a radical over here, there's a radical over here, and this is a lot of work. Why bother? And the answer is, well, because it's the rules. Radicals in the denominator are considered bad manners. But also, as you move on and as you start doing more and more with rational expressions and fractions, one of the things that comes up, for example, is common denominators. Common denominators are hard enough without having to deal with square roots, right? So for your common denominators, you want to get those nice and rational. In other words, in this case, we actually got it all the way to a whole number. We got it to 2. So that's going to be one of the reasons. Our denominators are going to be complicated enough. Let's keep them rational, not irrational. Okay, let's give it a try. Make sure, again, you've got lots of colors around. Ooh, maybe even in the right order and everything. Let us simplify these radical expressions. Before I get started, you are welcome to start these. Like, one of the best ways to practice math is to watch me introduce it, see the problem, pause the video, try it on your own, see how it goes. I'm going to warn you that when it comes to radicals, there are so many ways to do these problems. It is likely that if you try it on your own, you get a completely different method than if I do it. So don't worry too much about the method as long as you are following appropriate steps. So check it with me or with another person who knows math, or you're welcome to follow me, but there are going to be other ways to do this. That's all. I'm not suggesting this is the only way. So for example, someone who saw this rational expression or fraction might want to cancel the 4 and the 2. And I'm not going to do that right off. I'm actually going to look at that square root of 2 in the denominator and say, I need to take care of that. So I've got a radical in the denominator. Denominator. My hand does not like spelling that word. So, ooh, the sound of the bell. Another mathematician gets their like trident and horns and, you know, demonic wings. Maybe even me. Okay. So when I approach this, the first thing that I might look at is maybe could I combine the radicals in some way to reduce? And the answer is this is 3xy here. That's the radicand on top. 2 is the radicand on the bottom. They don't really have anything in common, so canceling is not going to be an option. So that's out. Okay, maybe what I want to do is bring in another radical 2 to simplify, right? To help this get out. So what does that even mean? Well, I'm going to take this 4 times the square root of 3xy all over 2 times the square root of radical 2. And I'm going to go ahead and multiply by, just like before, radical 2 over radical 2. Now it has to be times 1. It has to be the same thing top and bottom. Up on top, I get 4 radical 3xy radical 2. Down in the denominator, I get 2 radical 2 radical 2. Now let's take a look at how we can simplify this. So the first thing I can do is, since these are both square roots, the radical with an index of 2, I can combine them. So 3xy times 2. Down in the denominator, same thing. These are both square roots. So I can bring them together. Okay, well then, but then here, ooh, I could have simplified that up top. I got so excited. I've got the square root of 4 down there. The square root of 4, so I'm going to simplify up here. I get 6xy. Down in the denominator, the square root of 4, let's see if I can do this without smearing too much. This guy is actually equal to 2. So then I just get 4 times 6xy all over 4. And then wait a minute, I can reduce the 4s. And so then all together, I get radical 6xy. Woohoo! Woohoo! So far, so good. Hopefully that all makes sense. And we now have a radical, but it's not in the denominator. So that's what's important. This is in the numerator. The denominator is technically 1. So let's try another one. Or maybe 3. Okay, the second one. Okay, there isn't a lot of decision making that we need to do, because in this case, there's only a 1 up top, so there's nothing is gonna cancel. I have an x and a y trapped in a square root. Now, bears can get in through the bottom floor, so we want to get these out. So I'm going to write this bigger slightly and think to myself, if I could multiply times a square root over a square root, remembering that this factor has to equal 1, what could I multiply by to get both the x and the y out? And the answer is, if I've got an x and a y, I just multiply by another x and a y. So then I've got, up top, I've got radical xy times 1. Down the denominator, I've got 3 radical xy, radical xy. That's radical xy all over 3. And then I can combine this, xy, xy. And now some of you are looking at this going, oh my gosh, why don't you just finish it? And the answer is, well, I'm always thinking about the people who aren't watching the video, who are trying to follow the steps. And I'm trying to leave enough breadcrumbs for them to see, you know, if suddenly something suddenly changes and they don't know what it is, then the notes are not very helpful. So let's see, I've got x, x, y, y. So the x runs, yum, 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 yum. And the y's both run, yum, 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 yum. So the x and the y both can get out. So I've got radical xy. Down in the denominator, I've got 3xy. And again, a lot of normal, reasonable human beings would say, wait a minute. So you're telling me that this is bad and this is good after all this busy work? And I would say, yes, exactly. And then people just shake their head. And what I can say is these are the rules. And these are the rules that existed long before I was born, hundreds of years ago, I believe. And so these are the standards by which we do all this. So I'm just passing along these rules to try to help you figure them out. But they've existed, you know, possibly are etched at the center of the nucleus of every atom in a star. It's possible. You can't prove they're not. So let's go with that. Okay. And last thing, notice how tempting it is to cancel the x and the y. Or sorry, the x and the y and the y here, because they look like they match. Remember that inside a square root, an x and a y are only parts of an x and parts of a y. You can't cancel them with a full x and a full y. These are square roots of x and y, slightly different. Okay, next up, I've got the square root of a fraction. This is rule number 3. This is right out, no fractions inside radicals. So we could like yell and scream and throw marshmallows. But really what we have to do is we have to split up the radical. Now I said that, but let's talk about why I think that's the next step. Is there anything that will reduce? And the answer is no. We can't reduce this at all. And so what we're going to have to do is I will split it up, and then I have to remember, okay, where can radicals not be? So it says no radicals in the denominator. So I want to fix this one. So if I'm going to multiply by a radical on top and a radical on the bottom, and I'm going to remember that that has to equal 1. I want to multiply by something that will fix the 3a. So what will fix the 3a? Another 3a. So up top, I've got radical 7 times radical 3a. Down in the denominator, I've got radical 3a times radical 3a. So up top, 7 times 3a inside a radical. Down in the bottom, 3a times 3a. Up top, 21a. Down in the denominator, I can move some factors around and get 3 times 3 times a times a. The 3's go running. Yum, yum. The a's go running. Yum, yum. And I end up with radical 21a all over 3a. And I note that 7 times 3, there are no twins. So the bear is just like pacing outside going, I'm going to huff and I'm going to puff, except that wasn't a bear, was it? That was a wolf. But, you know, carnivores, furry carnivores of the forest. I'm going to huff and I'm going to puff and I'm going to blow your denominator down. And we say, no, you're not, because there's no radical in the denominator. And it's like, oh, you're right. Sorry. And then it walks away. Okay. Yeah. Shall we do one more problem? Why not? Shall we make it a super hard, ridiculously, stupidly hard problem? Yeah? Okay, let's do it. Dun, dun, dun! So this is a really hard problem. And the reason it's hard is that this is a plus. And so this is 2 terms. There are 2 terms in the denominator. And so if you simply multiply by radical x, you'll get 2 radical x up top, which is fine. And then you'll get, remember, it has to multiply times each of them, 5 radical x plus radical x times radical x, which is awesome. But 5 radical x plus x. So multiplying by radical x fixes this one, but then it infects the first term with a radical. So you just shifted the radical. There's still, there's, let me try using English. There's still a radical in the, it's my bête noire, spelling denominator. Denominator. Sad face. So clearly this is not as simple as the other ones, which is disappointing because after doing a couple of those, you're like, yeah, let's do it. We can do all of them. So this is the moment where I say, remember in the last video when I mentioned conjugates? So for example, 5 plus radical x, the conjugate would be 5 minus radical x. We're going to use that. So if there are 2 terms in the denominator and you've got a radical involved, come up with the conjugate for the expression in the denominator. I know, everyone's looking at this going, oh no, oh no, oh no. I know, but we're almost done. And then you will know everything. And you'll be able to go to your family and say, family, now I know everything. And they will all be like, wow, that is awesome and amazing. Have some cake. And that is the way it always is. And if they don't have cake, then you can say, where's my cake? And they have to, by law, get you cake. In fact, I plan, as soon as this video is over, I plan to remind my family that I know everything. And they will give me cake as well. Chocolate cake, if anyone is overhearing this video right now, with chocolate frosting and extra frosting. Maybe skip the cake and just give me a bowl of frosting. Okay, but that's for later. Oh, how did I do with distracting you from what I just wrote down? Hopefully I did a pretty good job, so you're not too panicky yet. And in all things, I'm going to remind you that for most algebra students, you are not going into mathematics. Some of you might be going into mathematics or engineering, in which case you kind of have to understand most of the topics. But for most people taking math, let's be honest, there are some topics that are, you don't have to know it as well because you're aiming for 70, 80, 90%. So, is this going to come up every day? If you're not a mathematician, no. If you are going into math, this will come up actually surprisingly frequently. If you're an engineer, it depends on what you do, but this will come up, so you should know it. If you are going to be a phlebotomist, I don't think this will come up very much at all. So you just got to get through this class, and then this will generally not be part of your life until perhaps you have kids or nieces or nephews or small, younger people who are in your life who are studying them. Or maybe older people, you never know. Let's get everyone back to school, right? Okay, so 5 plus radical x, I'm multiplying by 5 minus radical x, 5 minus radical x. So if I multiply across the numerator, it's 2 times the quantity 5 minus radical x. In the denominator, I've got 5 plus radical x, 5 minus radical x. Okay, so what I'm going to do is I'm going to kind of give myself some space right here. And I'm going to say 2 times the quantity 5 minus radical x. Distributive property. Can you see all the different techniques that we've been studying this year? They kind of all come together. So this is very cool. Think of all the things you've learned. This is pretty neat. 2 times 5 minus 2 times radical x, which is equal to 10 minus 2 times radical x. So that's going to be our numerator right there. Okay, what about the denominator? Well, hopefully you've just seen the other video where we talked about this, and I said, okay, if there are 2 terms times 2 terms, we got FOIL, right? A binomial times a binomial. So let's do FOIL. F, 5 times 5, O, 5 times the opposite of radical x, I, radical x times 5, and L minus radical x times radical x. Okay, so this is going to be right here 25 minus 5 radical x plus 5 radical x. I'm writing these in the opposite order so I can see that it's 5 radical x minus square root of x times square root of x is x. Notice these two cancel out, and I just get 25 minus x. This is the power of the conjugate. The conjugate, remember we talked about it, a plus b, a minus b gives you a squared minus b squared. Gets rid of the square root. Isn't that really cool? Okay, so the fraction, which was 2 times the quantity 5 minus radical x, all over 5 plus radical x, 5 minus radical x, is going to be 10 minus 2 radical x all over, and then the new denominator is 25 minus x. Now, can you reduce this? Well, it is possible. There is a common factor of 2 in the numerator. You could factor that, but you can't cancel it. There are no factors of 2 in the denominator. So I'm not going to even factor it out because I can't use it. I can't reduce it. So this is our final form. Now, if you look at this, oops, sorry. I'm not going to be able to show you the whole thing. Let's all point up here. So if you look here at where we started, and you look down here at where we ended, I think that a lot of really reasonable, normal human beings would say, this is way nicer looking than this. And I would say, you know, from an aesthetic point of view, yes, it is. But the rules of math are not what looks good, but what follows the rules. Really, that is. The rules of math are follow the rules. And the rules are, if you can simplify a radical, do it. There's only one radical here. It's radical x. So, you know, nothing to simplify there. No radicals in the denominator. Yep, no radicals in the denominator. No fractions inside radicals. No fractions inside radicals. These are the 3 rules. We did it. We have rationalized the denominator. Yay. We rationalized the denominator. So now I'm going to go rationalize why I get some cake. Maybe we'll have a little dance party and then I can have some cake. Woohoo, congratulations. We finished the section on radicals. Yay, dance party. Woohoo, dance party. Okay, have a good day. Congratulations on making it through almost 25 minutes of some of the hardest math there is. You guys are awesome and brilliant. And I hope you have a great day. Math on.